This is the fourth question. Oh yeah, one more question. Darn. But anyway, I'm gonna focus. There you go. Anyway, so this question is just saying, just fill in the blank, pretty much. Just find find KA from what you know. Anyway, so I know that this question might be intimidating and you don't even know where to start, okay? So the first step is always do a skit chart. Like, I know back from video 2, I emphasized how important skit chart is, okay? So that's one thing awesome about skit chart, is that if you don't know where the hell to start, you just start from skit chart and it will tell you everything. So, let's go ahead and do a skit chart. So we know that so we sort of know that I don't even know how to pronounce that. Putrescing, that thing found in rotten animal tissue. So the chemical that you found in rotten animal tissue is sort of like a weak base. You can see because it has ammonia in there and it has lone pair and stuff like that. So whenever you're on a test, you don't know what's acid or base. Generally, like very, very, very generally speaking, anything with nitrogen in there is considered as a base because there's a electron. So when you draw the Lewis dot structure, you'll see a lone pair on nitrogen. So that lone pair can be a negative property to attract the proton. And from the definition that given in class, we know that base is a proton acceptor. So nitrogen has the ability to accept another proton. So anyway, just skit chart. So base plus water, and you get a conjugated acid, and you see that little plus sign over there, right here, and you get a OH minus. Okay. Now we know at the beginning we have 0.1 mole per liter of your chemical that's found in rotten animal tissue. So 0.1 and minus x, 0.1 minus x, and so we stopped right there, and we know that, well, H2O is in liquid form, so we don't include that in the equilibrium, right? So let's just focus on the product right now. So we know that at the beginning there's no product form and change, which is x, and then you get both x's at the end. But except in the question, it says that, at equilibrium, actually the concentration of OH is given, which is 2.1 times 10 to the negative 3. So when we put that right here, we can see that, x is actually equals to 2.1 times 10 to the negative 3. So that also tells you that, your conjugated acid at equilibrium also has 2.1 times 10 to the negative 3 mole per liter. And we know here, so just go ahead for the equilibrium of your base is 0.1 minus x, which is 2.1 times 10 to the negative 3. It's 0.0979. So that is your equilibrium concentration for your acid, okay? So now, since we know KB, we know Ka. Well, it's funny, trying to find Ka. We don't know Ka. But KB, but we know that this is a base reaction, so we know that we can only written in the form of KB. So don't worry about Ka yet. Let's just find KB first, okay? So KB is your OH minus concentration times your conjugated acid over your base. Okay? Now you just have to plug that in. So it's just x, 0.1 minus x, and your KB would be that value over there. Okay? Now, since the question is asking for Ka, the relationship between Ka and Kb is that, put it here. So we know that Ka times Kb is equals to Kw. Or you could think of as pKa plus pKb equals 14. Same thing. So if you do this is like two ways to do it. So if you decided to go with this route, okay, so we know that Ka times Kb equals Kw. So in order to find Ka, you just have to divide Kb by, you just have to divide Kw over Kb. So you would get 2.22 times 10 to the negative 10 for Ka. Okay, so if you decide to go this route, you just have to take the negative log of KB to find Ka. So it's 14 minus 3.3463, which is the negative log of that. You would, and then pKa you get 9.65, and you take the 10 to the negative 9.653, you get this value as well. Okay, so just on test, this is very important between Ka and Kb. Ka, you can only get that from the acid reaction, and you can only get Kb from basic reaction. And sometimes in a question, when you need to find one of the concentration, like you need to find X, and it's a basic reaction, right? It could give you Ka, and of course, obviously, you can't solve X with Ka when you have a basic reaction. So in order to convert Ka to Kb, this route works, or this route works as well. Okay, I hope that helps. Yeah.